All right, in this last video, we're going to go ahead and work through example 11 and 12. So we're working still with implicit differentiation and figuring out where our equations or our curves would have horizontal tangent lines or vertical tangent lines. So for this one, how many points does the curve have a horizontal tangent line? And then they just want us to find the x-coordinates of these points. So to figure out horizontal tangent line, again, kind of a review from last time, is if you have a horizontal tangent line, that means your slope, excuse me, aka your derivative, would have to equal 0 because a horizontal line has a slope of 0. So we're going to go ahead and find our first derivative of this curve, and then we will set it equal to 0 to figure out what x-coordinates would produce that slope. So let's go ahead and do it. So we'll get 6y dy dx plus 2y dy dx minus 5y, oh, this should be 6y squared, excuse me, minus 5y to the 4th dy dx equals 4x to the 3rd minus 6x squared plus 2x. So I'm going to go ahead and all my dy dx's are already on one side of my equation, so I'll go ahead and pull that out as the greatest common factor. So dy dx 6y squared plus 2y minus 5y to the 4th. Nothing changed on the right-hand side. And so then now I can divide it on both sides by that. Awesome. So then now that I have my first derivative, basically I'm trying to figure out where my first derivative, aka my slope, equals 0, because that would be where I have a horizontal tangent line. So to do that, I just go ahead and I take my numerator, my 4x to the 3rd minus 6x squared plus 2x, and I set it equal to 0. So we're going to go ahead and work with that. Greatest common factor, 2x. And then I'll have 2x squared minus 3x plus 1. Okay, and then if you factor that using reverse box method, you'd end up with 2x, x. This looks like minus 1, minus 1. So then we would set each of those separately equal to 0 to find our solutions. So 2x equals 0, this would produce x equals 0. 2x minus 1 equals 0 would give me x equals 1/2. Then x minus 1 equals 0 would give me x equals 1. So those would be all of the points, so times 3 points, where your curve has a horizontal tangent line, and those are the x-coordinates of each of those points. So we did it. All right, last example. Determine the points at which the graph y to the 4th equals y squared minus x squared has either a horizontal or a vertical tangent line. So we're going to go ahead and find dy dx. So we'll get 4y cubed dy dx equals 2y dy dx minus 2x. Move that dy over and then pull out a GCF, so we'd have dy dx and then 4y cubed minus 2y will equal negative 2x. So then our first derivative would be negative 2x over 4y cubed minus 2y. And then I guess technically we could reduce all that. So then it would be 1x, 1y, and then 2. Cool. So to find where it has a horizontal tangent line, that means I set my numerator equal to 0. And to find a vertical tangent line, you would set your denominator equal to 0. So we can go ahead and for the first part, for my numerator, we'll do negative x equals 0. So x equals 0 would produce a horizontal tangent line, but we're trying to find points. So if I'm trying to find the point where I have a horizontal tangent line, I have to use my x value plug it back into my original equation. If I have x, that's how you find y. So if I do that, I'll get y to the 4th equals y squared. That's my equal sign. Minus 0 squared, which is just 0. And so then technically you should get y to the 4th minus y squared equals 0. Pull out a GCF of y squared. Y squared minus 1. And then this is a difference of squares, so y squared, y plus 1, y minus 1. So then these would all be places at each of these y values where you would have a horizontal tangent line with this x value. So your points that you would end up getting would be 0, 0, 0, negative 1, and 0, positive 1. Now we're going to do the same thing with our denominator. So go ahead and set our denominator equal to 0. So 2y cubed, minus y equals 0. Pull out the GCF. Lovely. Let's see. I don't think, well, this one, y equals 0, is an easy one. But then if I do 2y squared minus 1 equal to 0, oh, this one, watch this one, it's going to be crazy. Add 1 over, divide by 2, so you have y squared equals 1/2. Square root it. So we'll get y equals plus or minus 1 over the square root of 2, or if you rationalize it, 2 over the square root of 2. Goodness gracious, I'm going to need some more room to write. So you guys luckily, hopefully have a little bit more notebook space. I'm going to go over here and erase how I found my first derivative. Because I found my y values that make that true. But I'm not being asked for just the y values. I'm being asked for my x values as well. So now I'm going to go ahead, so from here, I combined this and this to get each of these. And from here, I'm going to combine my y values with my x values in my original equation. So let's go ahead and define those ones. So if I plug in, let's start with 0. So 0 to the 4th equals 0 squared minus x squared. Then I would get that 0 equals negative x squared, which means 0 would equal x squared. So x would equal 0. Okay, so that's one option. And then our other option would be if I plugged in positive or negative square root of 2 over 2. So let's do the positive one first. Hopefully we can make that leap. Give me a little more room. So if I plug in root 2 over 2 to the 4th equals root 2 over 2 squared minus x squared. Let's see, then I would get, oh, I guess it doesn't matter whether I plug in positive or negative, you get the same answer either way, because I'd be squaring it into the 4thing it, so we'll just have to do this once. And so we're going to do square root of 2 over 2 to the 4th. So square root of 2 to the 4th really means square root of 2 times itself 4 times, which would give me, let's see, 4. And then 2 to the 4th is 16. 4 over 16 would be 1/4. Beautiful. And then on this side, when I square it, it'd just be 2 on top, and then on the bottom, we'd get 4, so that's 1/2. And then 1/4 minus 1/2 is negative 1/4. So then x would equal 1/4, excuse me, x squared would equal 1/4, which means that x equals plus or minus 1/2. Okay, so there's going to be a lot of different things that happen with this piece. So basically, the first thing we have to check is do we have any that overlap? So let's write out all of our points that would count for your denominator equaling 0 for a vertical tangent line. So the first point, like these were my x values that I found. So this one, these two, good. And then those are going to go with those y values. Okay, so when I plugged in y equals 0, so I got 0 over 0, or 0 comma 0, excuse me. When I plugged in positive root 2 over 2, you could have gotten out a positive 1/2 or a negative 1/2. So either of those would work. And then when I plugged in negative root 2 over 2, I could have gotten out a positive 1/2 or a negative 1/2, either way. So there's really 5 points, and you can technically condense these all by writing just plus or minus root 2 over 2, comma, plus or minus 1/2. Right, so those technically there's 4 points right there. So those would be points where your denominator is equal to 0, where you'd have a vertical tangent line, and then the other one, 0 comma 0, would also be where you have a vertical tangent line. Now remember, one of the things you have to be careful of is the fact that this exists here and here, and so only one of those things can be true, and the denominator or vertical tangent lines tend to dominate the horizontal ones. So it's actually a false statement for our horizontal tangent lines. The numerator can equal 0, but if the denominator equals 0, it's definitely undefined. So that works for this one down here. So your points where your graph has a horizontal tangent line would be 0, -1, 0, 1. And your graph, the points where your graph would have a vertical tangent line would be 0, 0, and then plus or minus root 2 over 2, plus or minus 1/2. Awesome. So go ahead and practice and let me know if you have any questions.